I'm going to load this up on
Hey, what's up, everybody?
our channel. And here we go.
Right, that's set. Look at that. Look at that handsome face.
All right, we're loading and then we're waiting for it to load up.
Sweet.
Here we go. All right.
There's my trash can.
So let's look at the timing. It's at 50 seconds live right now. So let's look at the timing. It's at 50 seconds live right now.
That sound now.
Got it. All right, and then let me pull up. Let me type a comment, see if it pops up.
All right.
Here we go.
Beautiful.
Let's see it, try that again. We're testing connection here real quick. Yep. All right.
Woo! All right, I'll be able to see what's going on. That's awesome.
All right, and you're good to go.
All right, so today we're going to be building a pulse motor. We got options here, and this is why I suggest we're going to see who comes along, and then we're going to get going on this. We got big Papa coil right here. This is 6 26 gauge strands, and I believe it's about 1,000 turns a piece. So we're going to hook this up, at least one of them, to this bridge rectifier. But for drive, we've got this is a trifecta coil with two 26 gauge strands and one 32 gauge strand. I wanted to look at this, but we're gonna. This is up to the viewers. Gonna take this away. But this is a 4-filer coil as seen on YouTube. It's 50 turns exactly. 4 strands of 32 gauge. Last time I used it, it almost like melted, like right there, because it gets so hot. So I'm wondering if there's a way to hook it up so it won't get so hot and actually work the way it's supposed to. All right, so another thing I wanted to look at was that I have a whole spool of basically 1 millimeter wire, 3 pounds. Wanted to check that out. Maybe make a coil with that later on. And then for bi-filer pancake coil, I have 12 gauge wire. I don't know if it'll work because it's stranded wire. And that much I would like to know. Like if that would work, because that'd be easy. It's already bi-file. And then over here, we've got an experiment. I want to go north-south with this and have like 6 magnet nodes. So every other magnet would be like north-south. So just north, south, north, south, north, south, north. And hook the Hall effect up to that and see what happens. Choose one of these coils to run over there. this right here. This is a bearing. Open this up. Gotta get used to the trash can being where it is now.
Right.
I put it there to try and stay on top of all the mess that I generate by doing this. And then we have 3 battery packs. So we can actually hook up 3 parallel drive coils on a router that we pick. Wow, this thing's pretty heavy. Now, we can either do, yeah, we're going to do a different one. Because I got one of these inside this one. I either want to put 2 in there, or I want to use this on a different rotor. Because that one's a little wobbly. It's not straight. So, yeah, this is an awesome bearing. So is that one in there. So, we're going to give a little bit more time for people to get around. In that time, I can put together this rotor. I think I want to take it off the shaft. Huh. Okay. There we go. There's something on the shaft. I should probably clean it with some WD-40. But as you can see, that bearing hugs that shaft like nothing else. It's perfect. Just in case there's like any grime on it or whatever. It seemed like there was just that one spot that really got stuck on. Yeah, kind of dirty. Now, doesn't that look better? I mean, the new shine there. Now, I wanted to show you all something real quick before we get started. It wasn't. Oh, man. There we go. I'll put that under there for now. Yeah, it was this one. This one with the magnets facing up and down, or this way side to side, but this way up and down. We're going to put this right on that toroid magnet. Look at that.
Oh, it's good. It's still blurry. Let's see if I can. You can kind of see it. It's weird though.
Can you zoom in?
Let me get right where you are.
Yeah, okay.
There we go. You can see it. levitating.
That's beautiful.
And because of the square magnets field, the size of it.
Yeah, the combined field of the and the proximity makes it possible. And see, that's awesome. We got possibilities now. I think that's so neat. It'll spin forever. Well, not forever, but for a long time. But you can see it's just kind of resting on that spot. You can push it past the spot, is what I'm saying. If you put any pressure,
Yeah, you'll touch the magnet. Mm-hmm.
but I was just showing you that it's a smooth cascade all the way down the pole to where it touches. It goes all the way down, like without pause. There's no gunk down there preventing it from going down further, is what I'm saying. Oh, that is so neat. And that's even neater.
All right, so say what you want to do again.
All right, let's see here. What we want to do is we want to choose a rotor over here out of this one and this one. We're going to build a pulse motor real fast. So we want the 9-inch or the 14-inch. This one has 9 magnets on it, and this one has 12. Distance-wise, I'd say they're about the same. But this is 40 degrees of separation, and I believe this is 30. But since this one's 9-inch, what is it? 5 inches smaller, it's about the same distance apart. So, what we want to do is we want to choose one of these, and then we go over here. We get our drive coil going. Either going to be this one or mini Bedini over here. Got 6 26 gauge strands in both of them. In both of these. This one's going to be a generator coil though. Or this one. You got to choose. So either this for a drive, which is 226 and a 32. 333 strands or turns, my fault. And this one is about 1,000 turns of 26 and 28. Got one strand of 28 in that. And then we're going to use batteries for the power. These are 12-volt battery packs. Does it have the, here we go. It's got 2000 M.P.H. That's awesome. All right, so that'll be our power supply. And then we got our Eve distribution. Power distribution, so everything that needs to be hooked up with power will be hooked to this. We're going to get some DC voltage. We're going to hook up a bridge rectifier. And again, we're going to, you want to hook it up to this coil or to this coil. And we're going to get going on. See if we can get a pulse motor. And then if we want a cap or no cap. If we want a cap, this is the one we're hooking up.
So for those of you watching, we want to play an interactive, we would encourage you to play an interactive role and suggest which type of pulse motor you want us to build with all these parts.
Yeah, absolutely. This is, yeah, interactive is the key word. We want, I've done all this already, so we want you to, give your suggestions, please. We're using Hall effect sensor for the switching. We can do both, I guess, right?
Yeah.
All right, this is the 9. I'm gonna have to get it at it from the side here.
This is good film here.
The shaft is different. Shaft goes all the way through the table to the ground. And it's very magnetic. There's a lot of iron in
Let's see
it.
if we can see it. There it is right there.
And that's how that one spins.
You can see the levitation.
Yeah, levitation. The other one will levitate too. Well, they all levitate. That's great.
Yes, yes.
All right. Hey, what's up, Benjamin? Okay, you want to be a part of hooking that up? Gee. I kind of understand the cascading effect that you're talking about, but we only have one capacitor currently. So if we're only going to do one segment of what you're talking about, yeah, thank you very much. It didn't take much to figure it out, but it took a long time for some reason. The magnetic coupling here. It's very cool though. It takes a lot of stress off the bearings. But what I can do here, since we have like basically 3 coils going through this. So we basically have 3 coils going through this one coil. Well, it's a super cap. I can't take them off of this board. This is the only one I have right now. It's a cascading super cap hooked up in series, so. But like I was saying, this coil has 3 coils in it, so we can hook the capacitor up in between one of these strands and have it fire onto the next strand. You get what I'm saying? All right, so let's get a position for this. Put it right here. Now we need a diode, a rectifier diode. We can use this one, I guess. And we'll just do it all in this one coil right here. Or we could use this coil. Benjamin, which coil would you rather use? This one or the big one or the small one? Awesome. Thank you.
There you go.
Thank you very much. You have a good one too.
So he did say the 3-1 coil.
This one.
Mm-hmm.
Okay.
Cool. Thanks, man.
So I think I'm thinking what that's saying is he wants this one to charge the super cap to run this one.
Yeah, I think you're right. What do you think about that?
I think it's quite possible. I mean, we could run this one in series into itself. Huh, this is 28. Interesting. They're both. See, that's awesome. That's actually awesome. I thought this one only had the six strands of 26. They both have a 28 gauge strand now.
Beautiful.
Yeah. And that can be hooked up in parallel. Very cool.
So yeah, I think that's a good starting point. And it came from the crowd.
Heck yeah.
And if you want to do any changes in your head, just mention them as you're doing them.
All right. So what I want to do is I want to unscrew one of these Hall effect sensors because we're only going to be running one motor. Apparently. I love these precision tools I have. Even though I don't have any fine motor skills. They're awesome. Yeah, go figure.
You picked a great hobby for not having any fine motor skill. I'm just playing.
No, you know, right?
Let's get a close up.
The less time I take to get to my actual target, the better off I am.
It's sort of a hunt and peck kind of thing, but he's very proficient with it.
Yeah, I've been doing it for a while. All right, so that's done. Let's get our switches on. All right, so I like these. These are really cool. Like boat switches. All right, so that's a very small end right there. I don't really like how small it is. You get this is probably going to be the most frustrating part of the whole thing for everybody. It's me getting these.
You got to do it with both hands.
I got stuff in my hands.
Future.
In the future, I will do and recognize the struggle that everybody is facing when they're doing that. All right, so that'll clip on to the on. Now, I want to get shorter wire connectors, man. I don't need 3 feet.
Yeah, that
But
makes
I do
sense.
need the 14 gauge. I just need shorter ones than the ones that I have. And that I can't find on Amazon anywhere. You either got these or you got these. It's like, where's the ones that I need? Or there can be a different way, as long as I don't have to like get all soldered and everything. We're gonna leave this one over here. So get what he's saying. We don't even need to use the battery with what he was saying. I don't know, should we try? Yeah, let's give it a shot.
All right.
We'll keep this together. Just right. So we're gonna do it with the Bedini coil, not that one. I don't have any cores that'll fit this coil or that one. They're the same bobbin. There's no.
Oh, is that a thick core center?
Yeah, it's a fat one. It's about 3/4 of an inch. I don't have one. I have an inch and I have half an inch. So the reading, it won't be like super duper. And maybe that'd be a waste of a core though. Like wrap one of these half-inch ones, like with cotton or something, some twine or whatever, to make it fatter.
To make it fit.
Yeah, to make it fit. Maybe the twine might actually work. Like cotton, string, or twine. I could try that. Okay, so. Alright, we do have limitations. We only have 5 glue sticks.
Oh, buddy. It's glue stick time. They're on their way, aren't they?
No, I haven't ordered them yet.
Oh, no.
Yeah, no. I'm worried about things, online things. It's all good. All right, so that's lined up. This, I believe, will stay where it is. Oh. So we are gonna, there's no way we can get it spinning fast enough to make enough energy to turn that.
Okay.
So we're gonna have to, and it always turns out poorly when you turn it back in on the same rotor. But we're gonna try it again. So we do have to hook this up. We're gonna hook it up to the 32 gauge strand. And the drive coil, the 3-file coil. Hopefully we'll get enough pickup. We gotta get some of these strands separated. Right. So that's actually not what I wanted to do, but it would probably end up being all right. I want to do this. Get it on the power distribution. And then get another connect.
Sorry, guys. That's my trying to do a close-up. A little shaky. We'll get some equipment for that.
And I'm thinking it's going to be all right as long as we have a solid connect. All right, so now that one. Oh, that's the one thing I did forget. The transistors. Right here. I mean, they're not far. Oh, yeah, there they go. I want the little breadboard, not the big one. So, here we go. Good, we had everything. It's just in various places. I gotta cannibalize the other one real quick. Get the all-effect sensor up high enough. Okay. So I'm gonna put these wires in here real quick, these jumpers. And then we'll do them opposed first, and then we'll go down from there if we need to. Now, for the second, for this part of the coil is going to be charged by this. We want, do we want a transistor for that energy? Or is that where I keep screwing up by putting a transistor in there? Okay. Put this one in here. We got it. Oh, it's facing the wrong way. All right. So we got base connection. Emitter connection. And the collector connection. Well, that's the wrong one. That's the wrong one. There's got to be an easier way.
We'll get some hooks or something.
All right, so this and will connector, which is the middle pin. I don't remember whether the emitter is on the bottom, which would be the left. I think the emitter is on the right. As a matter of fact, positive. Alright, so the emitter's on the right. The base is on the left. And that emitter will connect here. Now, let's check our Hall effect sensor. Come on, man. So just go over the top, it'll be fine. I'm gonna go underneath it. All right, moment of truth. No, it isn't.
Close.
Close. We're very close. We're very, very close. We just need. Is this a long one? It is. These gotta be separated from the other ones. There we go. Perfect. We gotta hook up the black wire, the negative. You stay where I tell you to stay. Yeah, he's like, yeah, right. I'm a wire. I'm gonna do whatever I want to do. All right, now we're all hooked up. Let's do this. See what we're working. Nope. Huh. Yeah, I don't know. I'm guessing it's a battery. It might be the switch, I don't know. Let's just go over this real quick. Red to switch. So positive to switch. So the switch is working. I don't think there's any amps though. Or is it? It could be that I have this in backwards. selector is in the middle. I gotta change the red one and the blue one. All right.
If you guys type out any comments, we can see them on the big screen here in the room. So feel free.
It's weird. I just forgot what. Here we go.
Yep, we got a solid light now.
Now I'm thinking that I screwed up with this royally over here. We're gonna unscrew it. It was just a bad connect to the power distribution is what it was. Here we go. Let's give it a shot now.
Yeah. Boom. Nice work.
All right, so that is. I need to charge the battery. I don't know. I just took it out of the package.
I think so.
And that's just a 32 gauge strand at 333 turns.
Oh yeah, it's picking up.
Hells bells. But we are limited to 12 volts. That's awesome. We got that right. Now what I want to know is with the Hall effect sensor, can I run north-south on the other disc over here without a problem? That one, yep. That's awesome, man. We run on batteries again. Batteries!
Yay.
That's neat. All right, so what we want to do, two connections. Find a strand that we want to use. Do we want to use the 128 gauge strand or do we want to use one of the 26s? To hook up to the bridge here. I'm going to go with one of the 26s right now, and then we can always switch it. All right. So this is going to go into the negative of this, so that's going to go right here. And then this, and it's going to be hooked parallel. So we should get some good DC off of it. I wonder how many amps this thing is pushing. We're going to find out. Or how many amps it's using. That would be better. Oh, actually, that's going out. This needs to be coming in, so we gotta swap those. Perfect. Now, we're gonna use our multimeter. One of them, I got another one, so yay. I'm gonna prop it up. Right here. We're gonna get DC voltage reading. 1.5 volts. That is not a lot of volts. I know that coil, with the electrical tape around it, the big one, will definitely generate more voltage. But it's constantly going up. But I'm really starting to wonder if I hook up that 28, what it'll be. So, yeah, let's go 28. Perfect. And then this one will go here. 20. And it's actually generating less DC voltage. Huh. Well, all right, that's good to know. All right, so this will go to 1. Maybe it's slowing down. That could be a thing if battery was low. 1.7. Okay, so 26 it is. Now let's just see. We're gonna go with amps. We're overloaded at 2, overloaded at 20. 200, we're at 30 point, basically at 30 milliamps. All right, so I have another coil, but we're not going to do that today. I have another coil with 666 turns of 4 different gauges. So you can't run them in series, but you can run them parallel. It has a drive, it has a core, and it can generate up to 300 milliamps using the power supply. And I doubt we're going to get that with the battery because it goes up to about 16 volts with a bunch of amps. That sounded like it picked up a little bit. Hell yeah. Man, that is so nice. That is so nice. It can be nicer though. Definitely. If anybody has any suggestions on how I can clean this up and have it be modular and practical, hit me up. Let me know what your idea is. I'll see if it's practical in my situation. And if it is, I'll apply it. right, we're getting 40 milliamps now. That's awesome. All right, so one more thing real quick. Huh. Oh, maybe not. Let's think, do I have a rotor? No, I don't. There's this one here under the table, but I don't know if I want to use it because it's kind of, well, 50 milliamps. It's going up now because you moved it. Move the switch a little bit. But we want to go north, south. We want to do a north-south with this one and see how it goes. If somebody wants to like lay a couple lines on me about how that should work, that's how I want to set this one up. It is a little floppy, like a floppy disk, but until I build a new one, it should do. All right. That is powerful, man. Them combined is all the way up here.
Okay. Nice.
In like repulsion phase. So yeah, that's awesome. I'm gonna put that right here. All right, I gotta get the glue gun. And then we're gonna tape it up. We're gonna put some tape on it so they don't go flying everywhere. Yeah, I wanna do that. They're gonna be three stacked on three. Three stacks. I like threes. You can tell I got trifecta coils. I've got 333 turns. I've got 3 strands. I've got
3 people watching.
3 people watching. Thank you. I appreciate you. So it's gonna go like that. We're always gonna be repulsing the one before it. So. Yeah, that tape is gonna make it okay. It's gonna be all right. Three more to go. Then we gotta put the bearing in. It's better just to do them one at a time. All right. That's awesome. That's awesome. That's a closed running circuit. It's not plugged into the wall. And that anything that comes off of that is gold. Okay. Whoops. I'm definitely gonna need to get that tape on here. is that? Oh man. Okay. I should let it set. Yeah, we don't have a lot of time though. Yeah, we're running out of glue too. So. All right, we're just gonna put it down. Doing it like that is not working out. We're not done though. I'm just gonna put it down. Try doing it with both hands. Because we're so close. That's funny. That is so funny. I'm almost laughing. There we go. Wow. Mm. All right, we got them all set. North, south, north, south. Awesome. That's ready. We just need to put the tape on it. As soon as we find out where that tape is, we'll do that. But I'm gonna leave it there for now, because that was tricky. That was unexpectedly tricky. I'm trying to keep all this glue contained. I think this is bad. This is bad. Isn't good. Bad isn't good. And that's just with the 32 gauge strand of this little coil right here. There are two more strands that can provide power. You can either put them into a series circuit, 226 gauge strands to make a 666 gauge strand, or you turn strand, or you can just leave it as 233. To 333. I get my numbers mixed up. But this one is generating about 65 milliamps now. Between 55 and 65. Very choppy. That's the ampage. coming off of the 26 gauge strand. And the DC voltage now is 2. But you hear it pick up once I changed it from amps to voltage, because there's a low, when you test amps, there's a load applied. See, it's already up to 3.1. It's awesome. Because it doesn't take a lot of voltage to trigger certain things like transistors. 5 volts will trigger like a MOSFET. So you don't have to have much voltage, but what you do want is enough amps. I suggest, like, if you're going to run something, you want at least 100 milliamps as like a baseline. You want it to register on, say, your power supply, and it registers at 100 milliamps. That's awesome, man. I didn't even, when I first turned it on, I'm like, no, something's wrong. Something is definitely not wrong here. I brought my tachometer. Yeah, right here. This little bad boy right here. Heck yeah, that's a powerful coil right there. That's no joke. This little bad boy right here can throw some stuff. And for those of you that watch the channel, you can tell I'm in a different room, and my pegboard here is refurbished. I've redone my table that I work on, so it's not so messy. This battery, oh, I have no idea. I think it's 2000 M.A.H. It's like 2000 amp hours.
Yeah, this is the first time he's run it, so we'll time it and make a video on it.
Here, show them the side here. All right, we're at 5. Now we're at 5.2 DC volts. And I'm going to switch it to amps real quick. 141 milliamps. This is enough power right now to run another pulse motor. In my opinion, I haven't done it yet, but I think 100 milliamps is a good bench if you want to run something else. It's very cool. And then like, if you just, I've been trying to find the optimal place for the Hall effect sensor. That might have been it. That's good. I don't have my tachometer right now.
I know, I've seen it recently.
Yeah, oh, here it is. Yay.
All right.
Yes. All right, we're gonna get some speedometer readings here.
Oh yeah, 681.
On the balls. Usually has a decimal point. Well, that one says 1550 or 1156. $584.
Okay.
So I say right around 600 RPMs at the moment. And we're currently generating 4 steady DC volts. And that's just one strand in that coil that's hooked up. There are 3 strands. Just 32 gauges hooked up right now. I kind of want to hook up the other strands, but I want to hook them up through this coil. So let's do that. Got 5 volts and about 150 milliamps. Should I do it with it on? I kind of want to leave it on. And we gotta get another transistor. Luckily I anticipated this. So we're gonna hook one more strand up parallel to the first strand. You know what? If I touch that transistor, it's probably gonna fry, so. We'll check the flywheel action while I set this up. All right, now this is the tricky part. Setting this up is not easy. At least it's not easy because I don't know exactly how to do it. But what I think it goes like, it's going to go from the bridge rectifier. We can just get one of these. To the coil. Part to this one. And then this one. Oh, wrong one. This one will go into the collector of the transmitter. And if this works, we're good. If not, we'll probably think about wrapping it up. But or we'll just hook it directly to the battery, just to show you the more power that this little coil can do. All right, so oh man, I need a diode. Shoot. Yeah, let me go and get that. One of those little diode things. So that I can hook the Hall effect sensor up to this. Oh, wait a minute. I can hook it up to this little knob. And since we're only doing 2, that's all I really need. There we go. is going to go to the negative of the bridge rectifier. If I'm not mistaken, this is where I get confused. For what? We got 26 gauge, 32 gauge. That's what we're working with, both of those. Right now we're hooking up a 26 gauge to the bridge rectifier that's in here. We're using this to charge this to run this. And I think we're already kind of doing that. Let's turn this on so we get some switching. Oh yeah, you can hear that.
Yep.
Once the Hall effect sensor was activated, all the switching started to happen. So currently we have a battery pack running a 32 gauge strand off of a tip 42 transistor, which is then charging this coil run through a bridge rectifier to this transistor tip 42 through a 26 gauge wire. And I'm not sure whether that is, well, we can get some readings off of the bridge rectifier real quick. See what's actually making it through. Alright, so it's 3.9 volts, 4 volts. Oh, I think it's working right now. Oh, that's so neat. 4.1 volts. Getting a good amp rating. About 100 milliamps. Can't really tell whether or not it's working. I mean, you can, energy might be flowing through everything, right? Everything. But it doesn't mean it's making it better, you know? I don't know if there's really a way to tell unless, but you know, we can't really turn off, we can't turn off, we can unhook it. And should I unhook the battery real quick? Or shut it down? And see if it runs, or if the Hall effect sensor, that's the problem. Need 5 volts going through it for the Hall effect sensor to run. It needs to be spinning about that fast to make it to 5 volts. It's only at 4.7 right now. And there's no way to get it spinning that fast without the battery. So, that's awesome. I think it's working though, I really do. I think that's second 26 is kicking in. I think it's functioning. A good way to find out where to get this reading right here. Let's the coil just sitting on the side of the flywheel, not connected. You want me to turn off power? $5.92. So it's about the same amount. You want me to hit the switch? How much comes out of the coil just sitting on the side of the flywheel? You want DC voltage or AC voltage? See, 5.2, 5.3 volts are coming out of it right now.
Then yeah, cut it. And how much is coming out after you cut it?
All right, let's see.
In DC.
5.1, 5.1. It's tapering down, but I can kind of hear it functioning. It wants to function. It's just that the Hall effect sensor is not connected to the big coil, so it won't function unless the battery's turned on. Now, if I had a reed switch or a homemade reed switch hooked up, that would probably work, like wonderfully. One reason you don't need, for the really high frequency ones, you only need 3 volts to turn them on. And for the homemade ones, you don't need anything in particular. You just need one end clipped to the other end. It's really simple. And you get the max. In my opinion, if you can get it up to a high frequency, the homemade switches are going to be the way to go. Yeah, I could definitely, what would happen is that I would take these 2 leads from the positive and the negative that are hooked to the battery, and then I'd just hook them to the bridge rectifier. Let's do that.
All right.
All right, so actually, take this one. And this is gonna be positive. And then negative to the negative. Yeah, it's hard to switch things around and not get your wires screwed up. But that is okay. All right, the power went, the voltage on the reading went way down. I think it's working.
Light on.
Yeah. But like I said, in order for this to actually work, it's got to be going at extraordinary amounts of speed. And it probably took too long to hook that up for it to work. All right, wait a minute. Let's hook up this to the power. We'll hook up this to the emitter. Yeah, I don't know if it's working. Spin the flywheel a little faster by hand. I don't know that if I can. It's already going to like 600. Let's see.
Ooh.
Yeah, it definitely wasn't faster. Probably do it again. We're gonna try it one more time. I do feel like some torque there though. Let's try it.
Nice.
We do have a capacitor that we could be using. What do you think about the capacitor situation here? I think it's almost essential. Like hook a capacitor up right after the bridge rectifier. But we don't want to do that. We're not going to do that. It's hard to tell whether that's real. Does that look real to you? Does it look like it's either picking up speed or maintaining speed? Or does it still look like it's off my whip?
It's hard to tell.
It's hard to tell. That's true. Alright, so positive. Because the voltage meter is reading 0, so it's definitely flowing through the system. I mean, if it is legit, then I can stop it and start it up again. So we'll be able to do that. But first, I'm going to do this. Positive. Right. Just making sure I got that right. Alright, that should be good. Let me get that off of there. Okay. Oh. Yeah, I'm gonna put this one on there. Now it's a complete circuit. Alright. Here. This voltage is going up, it looks like. Or maybe I caught it at when it was fluxing. Yeah, it looks like it's going down. It's 1.2 volts right now. That's what I think it's. I don't know. Is that flywheel? What do you think that is? Is that flywheel or is that motion? I'm not even going to use the word. That's stupid. I'm not going to do that. Because me personally, I don't believe that that's really a thing. I think that there's lots in place to prevent that from happening. But if I can do it just by doing that, hell yeah. All right. But that is slowing down. If we can get it up to, I think it's the cap now that's in the way because we can get that up to like 2.75 volts. And it's only at 1.7. So, how are you going to take the cap out? Think real quick. Nah, it's alright. Yeah, we're not, this is a humbo jumbo now. I don't feel like messing with it. We have to take it, break it down, and start anew. We could do that. We're gonna have to do that later. Alright. I don't think he's gonna start, well, I mean, look at it go, man. I don't know. Yes, it's going up. Or no, it's going down. It's at 1.8. Now it's at 1.5. I forgot I spun it again. I was like, it's at 1.2. Now it's at 1.5. Oh my god. But no.
Nah.
No.
Stay tuned. Yeah.
Stay tuned, everybody. Oh my god, it's going up, bro.
Show it.
Well, it's fluctuating between 1.6. That's the cap. Oh my god, the cap's getting charged up.
That's what I was thinking. The cap's getting charged.
Bro.
You're doing it.
Yeah, that's gonna work, I think.
Mm-hmm.
If it doesn't, like, if it can charge fast enough for the rate of descent, is what I like to call it. When it starts slowing down, it's got to charge faster than that. But it is a huge cap, man. I do have individual ones, but we're gonna have to try that out on another day. But I think, yeah, there's a steady flow. 1.3, you stabilized. The flux is now at a lower level. We're at 1 point. Yeah, it's going down. It's all right though. We'll work it out. Hey, no, my God, dang. Maybe we just need a single cap or a 10 volt cap. It's a different capacitor.
So it might be using more than it's charging, or using the same, just a little less than it's charging.
I think it's taking more to charge. Like, yeah, the rate that it's using is greater than the rate that it's charging it.
Okay.
At least that's what it, I mean.
Well, if it's going up, then it's charging slightly more, right? Or is it the other way
What
around?
I'm saying is it's working on a pulse. So it's going up. Every time it hits a magnet, it goes up.
Got it.
And I just don't know whether it's spending faster It should be equal. But I think because of loss, it spends a little bit more than it generates.
Okay.
Because this is a really rudimentary system, that'd be great if I could get it going fast enough to actually charge, fast enough. Or maybe just changing the cap will fix everything. 1, 2, 3. Anyway, that's cool. I love that we can get it going on a battery pack. If we need more wire, we just hook one of these together in series, and that'll be good. All right, so I'm gonna wrap it up for now. Thank you very much for hanging with me, and we'll get this going. We'll get it right. Looks like it is going, but it is definitely getting slower, but slowly. And whatever it takes. Thank you very much. Peace out. Please subscribe. Have a wonderful day. Hit the notification bell. We do a live stream every Sunday, or we try to. And yeah, I post videos all the time with experiments and things that we do. A significant change, just real quick, because we already got this, was that the shaft goes all the way down to the ground now, making it way more stable than it was before. Yeah, and we'll get that rotor over there working with the 6 north-south. Hopefully having a Hall effect sensor will make it work right. Yeah, I'm gonna switch up the cap. Oh yeah, we're way down there now. All right, we'll switch up the cap and go from there. All right, thank you very much. Peace out. Bye now.